Hello, um, hello everyone, and welcome to the second espresso workshop and the first workshop of the day. The first one was on Monday during the opening ceremony, and this workshop is going to be an extension of the one on Monday. So by the end of this workshop, you'll have all the knowledge you need to be able to start building your own project that benefits from the Espresso network and that is able to read parse transaction and do something out of it. And so in order to do this, you're gonna know how to learn how to deploy your very own caffeinated node, node. So in this workshop, these are the steps that we are gonna go through. It's pretty simple and straightforward in the names, but like project overview of the little application we've built, some of the prerequisites, what exactly is a caffeinated node and why do you need it, some of the setup instructions in order to get it up and running, and then same thing with the example project, so tweaking with the configurations for you to be able to take advantage of the caffeinated node which you've deployed. Then there's a specific section of troubleshooting. We'll go over some of them. We'll very quickly go over what updates you need in order to, well, not run everything on the testnet, but have it running on the mainnet. We'll also go over a specific section on how to, well, deploy your caffeinated node on the cloud, so not only locally, but keep it on EC2 instance, kind of similarly to what we've done in the first guide, which we broadcasted on Monday. And in the end, we'll do some tweaks to the monitoring application for it to be able to properly be calling the caffeinated node, which is running on the cloud. So quick project overview and what we're actually going to go over. The idea of this application was just to show you how you can benefit from the caffeinated node in order to parse transactions. So we've built this small Go-based application that is going to monitor the Espresso network through the Caff node and monitor specific transactions that could be suspicious. So let's say, for example, you want to make sure that one specific address doesn't get all its fund removed at once. So you can tweak it and tweak the application to, well, be able to detect and log wallet drains, for example. So project continuously read and parse the transactions and then filters these transactions based on specific values, and then will alert the user. Let's say, oh, we've detected this specific transaction. All right. So in terms of prerequisite, which I've kind of mentioned before, you need to have gone through the guide, which is deploying an Arbitrum Nitro rollup integrated with Espresso, which again we've seen on Monday. It doesn't mean you cannot follow this guide through with us. It's going to be very helpful and everything. But in order to you're on your own run all of this, you will need to have your own Nitro rollup deployed. And so, as a matter of fact, we're basically using the same repositories. So Espresso built something real, which has the configurations to deploy and run your your rollup. And same thing with the hackathon example, which we used to basically, in a specific branch in the previous guide, read transactions from Hotshot through the query API. The only thing is we used to not only just get just bytes, but not really able to identify anything about these transactions themselves, which is why we extend it as well in the same project right here. And so just to give you a little order of how things happen and what exactly is a caffeinated node. So think as the top part, basically the same thing as we've seen in the previous guide in the idea. So you send as a user transaction to your rollup, which goes to the sequencer batch poster to the Espresso network. Well, in our case, consider that the caffeinated node as being this JSON-RPC node, basically for that specific rollup. So you specify, you set it up is exactly specifically to be connected to the rollup you've deployed, which is going to read the Espresso network for that specific rollup and be able to, well, you'll be then able to do any kind of RPC rollup calls you would make generally, but to that specific caffeinated node. And so you as a user will be able to, well, get transaction status like the sender, the value, the destination, and all of these things. So now that this is said and done, I hope this makes a bit more sense to you. Let's just get started. All right. So these are small indications that you have all this information. So first of all, is the Espresso build something real repository when we're going to ask you to update the configuration? So pretty straightforward. Is kind of similarly to the full node and all the information we had. There is this new folder right here called calf node in the configuration. And so go on this calfnode.json. I hope you can see properly. And so update the specific values mentioned in the guide. So we have here the chain ID, which is going to be the same thing right here as the namespace, which is the chain ID of the rollup you've deployed in the first guide. Here we've got the Hotshot URL and Espresso T verifier, similar to the full node for a testnet. So you'll see the equivalents in the mainnet section for doing all of this on the mainnet. Two important parts are WebSocket Arbitrum simple RPC URL. So your RPC provider URL plus the API key, slash the API key. So depending on which RPC provider you decided to use. As you can see here, it mentions the sequencer URL of the Nitro node, which is on port 8547, which we've seen in the previous guide. You do not need to modify, but it shows you that the calf node is also listening to the rollup which you've deployed. And last thing is this specific next hotshot block. So basically, this is going to specify the block to the point where your calf node is going to start syncing, right? So if you forget to update this value, let's say if you go to the Explorer, so we have the Explorer address in here in the guide, all right? But if you go to the Explorer address here, you get this specific hotshot latest block value. As you can see, it can update very quickly. So make sure that when you run Docker Compose up and build your container, you update the specific values, because otherwise your caffeinated node could take a lot of time to resync all these blocks to the point you've mentioned here. So every time you run the container, update the specific value right there. All right, perfect. Okay, now that this is said, an addition thing you need to do, like I've mentioned previously, right here, your calf node is kind of listening to the Nitro node itself. So you need to provide as well the configuration file of the L2 chain info. So this value which you've updated in the previous guide with all your addresses and all of that, you can find it in the first guide. Well, you just copy this L2.chainInfo and copy and paste it directly in the configuration right here. So similarly to the way architecture is done, so of the repository, so full node L2, here you have calf node and the L2 chain info. And additionally, you're going to want your caffeinated node to be listening to the same state, to the same database as your rollup. So we've specified in the guide. Make sure that before doing so you shut down the container of the rollup. All right, then you copy the database folder right there and paste it from in the calf node directory. So let me show you in the code itself right here. So you have this database folder right here. Well, copy it when the Docker when the container is down, and paste it in the calf node folder right here. This way, the caffeinated node and the rollup will be exactly in sync, and will be able to run concurrently. All right. And so once this is done, I'm not gonna show it to you right now because I did it on the cloud, and it'll be easier when I show it a bit later. But make sure you first of all go in the main folder, you run Docker Compose up, and then you navigate in the calf node and you do the exact same thing. This is first gonna deploy the rollup and then deploy the calf node. So all these steps are mentioned right here. Docker Compose up, Docker Compose up. You can do a little dash D if you wanted to. If you don't want the logs to be directly in the in the terminal itself. All right, so if you followed all the steps, it should work perfectly. If you come across any error, go to the troubleshooting section. We'll go together on it. But basically, once this is done and you have it up and running, then this is when you're going to set up the example project. So example project is in the, like I've said, hackathon example under the main branch. What is actually important, very quickly, this is, I'm going to just explain for the sake of it. We're using this specific Go Ethereum version to be able to, well, call the functions we want and everything. So we made sure that we just downloaded the submodule, so everybody starts with the same repository and you don't come across that many errors. This is why we've specified all those steps here to install the dependencies. All right, so submodule update and everything. All right, so the important part we are interested in this repository is this config file. And so in this config file, we have the config.json. So in the config.json, we have those specific values which we've mentioned. So here is going to be your host. So basically, if it's on the local host on your computer, local host, otherwise the IPv4 address. Same thing here. So you have the value at which you want to be alerted. So let's say if it's just some simple, easy transaction, don't mention, but at some point you'd be like, oh, well, if a transaction from this address, which has like more than, I don't know, 2 ETH, which is a pretty big amount, no matter the price, well, notify me. So for example, in my case right here, let's start, we'll start with 20, and I've actually deployed on the cloud to this address, so I've replaced localhost with this address, and this is the specific address I want to be monitoring. All right, so we'll go over this in a second. All right, so update these configurations. There's all the information which I've mentioned right here that are important. For example, value amount is in way. Let's say localhost if you're running locally, blah, blah, blah. So all the information that you need in order to do this. All right. Now, okay, we can basically run it right now. I mean, it's on the cloud. I'll go over it, but we can just do go run. Now, the thing is, it's going to tell us that the application is getting started. So starting the application, searching for a transaction at a process block. Now, the thing is, if we go here, then we need to be able to send transactions, right? So there are multiple ways to send transactions. The following ways are either to the command line right here, to the specific command line. So here, don't forget you send transactions to the rollup, not to the caffeinated node. So either this or the URL, the IPv4 address with this specific port, or you use the transaction generator, which we've seen in the first guide, and then we're going to go over quickly together right here. So if you see there's this transaction generator folder, you go to the index file, and here you have so the rollup RPC URL, so localhost 127 whatever, or the IPv4 address. You see same again sending to the rollup with destination address and signer, which is basically the from address that we're monitoring from. All right. And so in our case, let me show you very quickly, 2 seconds. I'm just going to go in the log groups, and so we can actually see what's happening. So I'll go over it in a quick second how it happens, but let's say we go to the Nitro node, which is actually running, and here we go to the Caf node, which is also running. So this is getting the logs on AWS. I'll show you how to do it in a second. Right now, let's say we are listening right here. We've set the value to 20. I'm sending 15, right? I'm sending a transaction, where was it? No, it was actually here. All right, you see, I'm sending transactions that are valued 15. Let me send another one. And then we wait the signal a few seconds, and you see that, well, awesome, we've sent a transaction with value 15. Now, if we go on the on the listener right here, well, you see it didn't find a specific transaction, right? However, if we go in the logs, right, and we check at what was going on, and we go down, so 827, let's go down, and we see here, added message to queue 515, right? And same thing with the rollup logs. If you've already did the first part of the guide, you should see. So yeah, enqueued pending transaction to Espresso was successful for position 515, right? So you see it went over 515. It didn't see any. It went to 16 and now it's looking for. So which means that it didn't notify or alert specifically. Now, if we stop it right now and reduce this value to, for example, 10 in order to be notified, let's run this again and see what happens. So we'll wait for the application to start. So the application started, and you see it found the previous transaction which we've just done, which was like for latest block 516. You see, because actually I didn't stop the transaction generator, which is why we have sent a lot of transaction, and which is why the the hackathon example repo was able to find all these transactions that are quickly being processed, which shows us that, well, everything is working perfectly like we want to. Now, awesome. Now that you get an idea of how things work, I'm going to go a bit over the cloud deployment section, right? And what we really need to understand in that specific case is, not now exactly. We'll first go to some of the troubleshooting and explain some of the messages. So if you've seen right here in the logs, you get a lot of these specific messages: failed to fetch, error while getting, blah, blah, blah. This is for the CAF node itself. Well, the thing is, considering the CAF node processes, tries to process block at a very high speed, well, it doesn't necessarily find a block every time, which is why you get a lot of these log messages, but doesn't mean it's a specific error that and your code is not working, right? So which we kind of see right now. Same thing is if you get to transaction detection messages. So this is mostly for the caffeinated node, but you're supposed to see added message to queue for a certain message, which we've actually seen. And then you can at some point get to this step which says produce block, blah, blah, blah. So if we see when the transactions were sent, that was probably very low. Well, at some point, I need to find the messages themselves, but you should see, so initial state, last block app, produce block. So this means that it's actually running up properly. Awesome. Next things you can find and come across is the specific no transaction found, blah, blah, and you get these messages at a very, very high throughput, right? And the reason is, this is because you have not updated the next hotshot block from the Espresso Explorer. And so if you forget to update it, then it might take a very long time to resync with everything, and at the same time be burning through your RPC requests. Awesome. Next little error you can you generally come across if you restart both Docker containers. Sometimes it happens that, well, the database get out of sync. So make sure that you put up to date your rollup, close the container, copy paste the database folder, and then rerun everything smoothly, and it should work. So I've mentioned right before in this section right here the number of RPC limits. Keep in mind that these are some of the polling intervals that allow you to kind of be flexible in the number of RPC calls that are being made. Bear in mind that the code is very, for the Nitro Arbitrum code is very RPC heavy. So it may be that you be spend like burning kind of through some rate limits. So, and actually other way around, if you have an advanced plan and you want to have it more than production ready, so, well, feel free to even reduce those intervals. It's up to you to kind of work on the on the architecture and where how you want your rollup to be running, right? And so these can be found in these both specific config files. All right. And last thing is monitoring issue. Like we've seen right here in this part, it was saying searching for transaction at last process block 516. If you do not see that specific value right here, it means that, well, your RPC node is not properly set up, or it's the database is in the wrong place, or whatever the structure is can be wrong. The idea is you need to be to potentially recopy the database and everything, and we've added some of the solutions right here. Right here is update for listening to mainnet. We're not going to go over it right now that much, but just mind that this is the information that you need to update. So we're just indicating you. Some of it is already in the previous guide, which made accessible right here, but we're not going to go over it now. All right, so in this specific section, which I was about to tell just before, so for deploying your Caffeinated node on the cloud, basically we're trying to reproduce the exact kind of repository structure we had in the Espresso build something real repository, which you've seen here, right? So in the previous section, we've shown you how to put your deploy your rollup on the cloud. Well, now the thing is, we're actually gonna, through all these steps in the guide, be creating this Caff node directory, right? So, like for example, first thing, you're creating the database config wasm inside Caff node. You're giving the corresponding write access for your rollup to be updating the database and Caff node from inside the EC2 instance, and then here, like you see, transferring the configuration files, running the copy pasting the database like I've mentioned before. Same thing from inside of these the instance if you want to, and so this will just reproduce the exact same architecture repository structure you had. And last thing is the enable CloudWatch logging. So CloudWatch logging is the section I was mentioning right before when we've seen the CloudWatches here, because it's instead of having like everything running locally on your computer and probably taking a lot of processing power and all of that, you could directly do it in the cloud and then go and see the logs in the cloud itself. All right, so basically in order to do this, well, you need to create some log groups and stuff, which is similar to the previous guide, which is linked here. But basically what you need to add is this specific logging section, which I've actually commented out right here. So you can add this one and change the name of the region depending. I'm in Eastern zone, so this is why. But like depending on where you are in the world, you can change this specific region. And if you have created the proper log groups and everything, when you're going to run Docker Compose up, it's going to link to CloudWatch if you followed all the steps that you can see in the previous guide. So do not forget to go over this. Awesome. And so last thing, if you did this, then you've modified the Docker Compose file, you move it to the instance in the proper location, and then same thing, Docker Compose up in the rollup, Docker Compose up in Caff node. So same with some information and stuff that you might find useful when doing the procedure. All right, and so last thing is, as you can see right now, we're actually doing calls to the Caff node, which is located in the EC2 instance. So you may come across, if you didn't specify the proper security rules, you may come across some errors with regards to, well, accessing certain ports of your EC2 instance that you want to be like exposing. So let's say let's go in this EC2 instance. So let's say you have your specific instance which is running. So you actually click on the instance ID, go in the security tab, find the security group, and edit the inbound rules right here to be exposing those ports such that you can do custom TCP requests to these specific ports. All right, so that should be it for as a building blocks and all the tools and steps you need in order to start reading transactions from Espresso, building applications that can actually do something about it. So in this specific in the Dora Hacks hackathon page, there is this ideas to build tab with some of the ideas. Is just some indications that can help you to get an idea of what you can build upon and upon this application extend. So one, for example, that I can go over is, let's say, for example, you have an NFT marketplace and you want to make it cross-chain. Well, the idea is, if you mint your NFT on a rollup A, which is integrated with Espresso, if you have your caffeinated node, which is listening to that specific rollup, well, you can take advantage of this fast confirmation that you get in a couple of seconds from the rollup A, such that your app can actually mint the NFT on the rollup B without having to wait for L1 finality and avoiding reorgs and all that kind of things. So this is just an idea of how things can be extended. You can find other things if you have, or even ideas you may have. This is up to your freedom and to decide and be original and all of that. But it was just to give you an idea of it. All right, so I hope this was clear enough for you and that you have all the necessary information and steps to be building super cool application and use cases. So enjoy the rest of the workshop talks this afternoon, and take care, everyone. Happy coding.
Awesome. Excellent. Mariana, we're back up on stage. Did you have a question for Jean?
Yeah, I think we need to bring Jean back to the stage.
Jean, you want to turn on your camera and mic? Cool.
Yes, can you hear me?
Yes.
Yeah.
Jean, the question I have is more like in deploying the caffeinated node. Can you explain for someone that's like a dev that never deployed rollup before, if they should be doing this for all the rollups they deployed? In each case, they would be deploying more caffeinated nodes. And what is the main function of a caffeinated node?
Yeah, basically that's what I was trying to explain at the beginning in the early section. The idea is that each caffeinated node is specific to one rollup that you're deploying, right? So as you can see in the for example logs, the caffeinated node is simply putting out this kind of RPC. It's basically this RPC node that allows you to do calls to this rollup integrated with the Espresso network. So if you want to build different rollups and get to listen from both sides, then you would have to deploy one CAF node itself per rollup. And I hope that answers your question.
Yeah, it answers. So basically, if you're reading from rollup A, you need to have deployed a caffeinated node on rollup A. But if you need to do the opposite, that is reading from rollup B, you also need to like deploy a caffeinated node on rollup B. That is normal, like how we read transactions, interact with the nodes of a blockchain.
Yeah, and also depending on the kind of let's say application you want to build or kind of cross-chain interactions, maybe in some cases you would only need to have one rollup that is that you're listening to get those fast confirmations. So it really depends on the kind of use case you want to build. If you want to do bi-directional communication, then it would be best to have deployed 2 CAF nodes. But yeah, in the idea, that's exactly this.
Yeah, for a hackathon, I think like if you're just doing a hackathon project, depending the level of like complexity you want to bring in your cross-chain app, would make sense to deploy 2 caffeinated nodes. But like for the sake of like the understanding of the action, I think 1 caffeinated node can do a lot of the work. Thank you, Jean. Thank you a lot. I don't know if you have another question. If not, we can go to our next speaker.